Today we're going to be talking about the history of the atom and the many different contributions that were made to the atomic theory to allow us to think of the atom as we do today. So you can see on the list here that I have 6 different models that we're going to be talking about. There are many more and many other scientists that have made contributions to the atomic theory, but these are the 6 that I would like to shine some light on. So by the end of this PowerPoint, you should be able to identify some of the contributions that were made to the atomic theory and know that there are many scientists that have helped create this, and also be able to draw some of these diagrams as well. So the first model we're going to be talking about is the Greek model. This is about 2100 plus years old. It was created by a Greek philosopher named Democritus, and he proposed his atomic theory in about 400 BC. He was also the person who coined the term atom, but he speaks Greek, so what he called it was the atomos, which means it's indivisible. So he believed that matter could not be divided, which is where he came up with the word atomos. And he also thought that atoms were made of the same material and they just had different shapes and sizes. So if you're looking at this information and you're thinking that you don't recognize a lot of it, that it's very new to you, that would be because a lot of this information has been expanded on. We don't use much of it anymore. So if you look up in the right-hand side there, you can see Democritus's model, and you can see that it's very bare minimum. It's basically just a circle. There's no detail, there's nothing that shows what is in the model, because he believed that it was just one thing that makes up an atom. Then if we move on to Dalton's model, this was named after a scientist named John Dalton, and he proposed his atomic theory in about 1803, which he stated that all elements are made of atoms, atoms of the same elements are alike, and atoms of different elements are different, and that compounds are formed when 2 or more elements are combined. So if you're looking at this information and you are recognizing some of it and you think that, hey, you know what, this is a lot of what we use today, we do use a form of it. It's not exactly to Dalton's words per se, but a lot of it was used to build on and create different models. So if you see his model there, it is also very bare minimum, nothing showing any detail, not identifying that there are multiple different pieces, because he didn't do a lot of scientific studies. So he doesn't really know what's inside this yet. So Thomson's model. This was named after a scientist called J.J. Thomson. He proved that an atom can be divided into smaller parts. So he was the first one to suggest that there were such things as electrons and protons. And he was doing an experiment with a cathode ray tube, and he discovered what he calls the corpuscles, which we now call electrons. And in 1897, he came up with his plum pudding model, which states that there's positively charged particles inside this atom that are evenly spaced out, and the electrons are just distributed around them. There's no rhyme or reason to the electrons except for they're based on the space of the protons. If you look at his model there, you can see that there's more detail. It shows the protons, it shows the electrons, but you'll notice that it doesn't look like the model you're probably used to seeing, and that's because we haven't come that far yet. So Rutherford's model. This was named after Ernest Rutherford, and in 1909 he performed a gold foil experiment, which allowed him to discover more characteristics about the atom than anyone before him was able to. So he found that the atom is mostly empty space, and that there was a thing called the nucleus, which was very dense and made up of very positively charged particles, those lovely protons, and it was in the center of the atom. And then he also found that the protons were surrounded by negatively charged particles, those lovely electrons, but again, most of the atom was empty. So he took what he had learned from Thomson and expanded on it. He did some more digging, he did more experiments, and figured out that they're not exactly what the plum pudding model says they are. There is space, and the atom is a lot of empty space. And then we have Bohr's model. This was named after Niels Bohr, and in 1913, he proposed the idea that the electrons move in orbits around the nucleus. So these orbits are called energy levels, if you've ever heard that term before. And he believed that the electrons could jump from one energy level to the other. And each orbit had a certain distance from the nucleus and could hold a certain number of electrons. If you look at his model there, you can see that there is the nucleus with the protons and the neutrons inside it, and then there's circles, and that's where you can see the electrons. These are the energy levels. And when we start talking about drawing atomic models and what they look like, we are going to be using a version of Bohr's model because it's the easiest way to draw. So then finally, we've got the wave, or also known as the quantum model, which is the model that we typically use today. So this is based on wave mechanics, and they also used Bohr's and Rutherford's models to help create this. And it found out that electrons don't move in a definite path. They don't stay in their energy levels. They don't move in orbits around the nucleus. They kind of move at random. And it still states that there's a small positively charged nucleus in the center that is surrounded by many electrons. And if there is enough electrons, most atoms are neutral. So if you're looking at this picture and you're kind of like, I don't recognize this, that is because the wave in quantum model is something that you will start using in chemistry class. We may touch on it just a little bit and show you kind of what everything looks like, but not too much in depth until you move into chemistry. So this picture just kind of sums up everything that we've learned. It doesn't have Democritus's model on here, but if you see and you remember, his and Dalton's model were very similar. So we've got Dalton's model, and then Thomson expanded a little bit and created his plum pudding model, and this shows the protons and electrons just kind of floating around in there. And then Rutherford's model with its orbits and being spaced away from each other, and then Bohr's model, which has the energy levels, and the quantum model. If you look in there in the quantum model and you see those little lobes, that's what I'm talking about. That there is a lot of information that goes along with the quantum model, and I may touch on it just a little bit, but you will learn more about it in chemistry class. So basically, to sum this all up, the atomic theory started in about 400 BC with Democritus, and slowly going down the line as more experiments were being done and science was ever expanding, we came up with the model that we use today. There are some very interesting people that have helped make some amazing discoveries in this field. So if you would like to, take the time and research this as well. That sums up the lesson for today. Have a great day.